Hello everyone. In this video I'll complete the last part of exercises of lesson 4.4 curve sketching. We reach question number 16. Sketch the graph of the function f of x equal x minus 1 to the power 5. The domain of this function is all real numbers since it is polynomial of degree 5. To find x-intercept, we set y equals 0 and solve the equation for x. So x minus 1 to the power 5 equals 0. Then x minus 1 equals 0. Take the fifth root of the both sides. Then x equal 1 is the x-intercept point for this function. 1, 0. For y-intercept, we set x equals 0 and solve the equation for y. Therefore, y equal to 0 minus 1 to the power 5 equal to negative 1. 0 minus 1 to the power 5, negative 1. Therefore, the point 0, negative 1 is y-intercept for this function. For symmetric, odd minus even, neither, to the power 5, neither. Therefore, the function is not symmetric, nor with y-axis, neither with origin. No symmetric. The function has no vertical asymptote since the domain is R and the function is not function. Also, the function has no horizontal asymptote since the function goes to positive infinity and negative infinity when x approach to negative positive infinity. And the function has no slant asymptote because it is not rational number function. So there is no vertical, horizontal, and slant asymptote. To find the interval of increasing and decreasing and local extrema function for this function, we find the first derivative, 5 times x minus 1 to the power 4, set it equals 0 and find the critical point. Divide both sides by 5, then x minus 1 to the power 4 equal 0. Take the 4 fourth root for the both sides, then x minus 1 equals 0. Therefore, x equal 1 is critical value for this function. Find the sign of the first derivative before and after 1. Before 1, take 0, 0 minus 1, negative 1 to the power 4, 1 times 5, positive value. After 1, take 2, 2 minus 1, 1 to the power 4, 1 times 5, also positive value. Then the function is always increasing. Infinity to 1, union 1 to positive infinity, positive infinity. To find the inflection point and the interval of concavity of this function, find the second derivative, f double prime of x equal to 20, x minus 1 to the power 3. Set it equals 0. Divide both sides by 20. X minus 1 to the power 3 equals 0. Take the third root for the both sides. X minus 1 equals 0. Then x equal 1 is possible an inflection point for this function. Find the sign of the second derivative before and after 1. Before 1, take 0. 0 minus 1, negative 1 to the power 3, negative 1 times 20, negative value. The function is convex in this interval. After 1, take 2. 2 minus 1, 1 to the power 3, 1 times 20, positive value. The function is concave in this interval. Therefore, from negative infinity to 1, the function is convex. And from 1 to positive infinity, the function is concave. And the point 1, substitute 1 in this function. 1, 0 is an inflection point for this function. The graph of this function will be, this is the axis. We have x-intercept point at 1, 0 and y-intercept point at 0, negative 1. An inflection point at 1, 0. After 1, the function is concave. Before 1, the function is convex. And the function is increasing everywhere. Question number 17. Sketch the graph of the function f of x equal x times square root 9 minus x squared. To find the domain of this function, we set 9 minus x power 2 greater than or equal 0. Factorize by difference of two squares, 3 minus x, 3 plus x greater than or equal 0. You can review the lesson of domain and range to find that the domain of this function is from negative 3 to 3. For x-intercept, we set y equals 0, then solve the equation for x. Therefore, x square root 9 minus x power 2 equals 0. Quadratic both sides, x power 2, 9 minus x power 2 equals 0. Factorize difference of two square, then x power 2, 3 minus x, 3 plus x equals 0. Therefore, either x power 2 equals 0, then x equals 0, or 3 minus x equals 0, then x equals 3, or 3 plus x equals 0, then x equals negative 3. Therefore, we have 3 x-intercepts point. 0, 0, 0, negative 3, 0, and 3, 0. For y-intercept, we set x equals 0 and solve the equation for y. Therefore, y equal to 0 times 9 minus 0 square equals 0. Therefore, 0, 0 is only the y-intercept for this function. The function has no vertical asymptote. The function also has no horizontal asymptote, since the function is undefined when x approach to positive or negative infinity. Also, the function has no slant asymptote, since the function is not rational. So there is no vertical, horizontal, and slant asymptote. For symmetric, we have odd function times square root even function minus even function equal to even minus even, even square root of even, odd times even equal odd. Therefore, we have function symmetric with origin. To find the interval of increasing and decreasing, we find the first derivative of this function. F prime of x equal to, we deal with this function as a multiplication of two functions. The first function is x, the second function is square root 9 minus x power 2. So the first function, x, times the derivative of the second function, negative 2x over 2 square root 9 minus x power 2 plus the second function times the derivative of the first function, 1, 9 minus x power 2. Reduce 2 with 2, multiply x with x, then x times x power 2 over square root 9 minus x power 2 plus square root 9 minus x power 2. Simplify this derivative. The common denominator is not square root 9 minus x power 2, x power 2, or negative x power 2, plus square root 9 minus x power 2 times square root 9 minus x power 2, 9 minus x power 2 equals to negative 2x power 2 plus 9 over square root 9 minus x power 2. Set it equals 0. Cross multiplication. Then negative 2x power 2 plus 9 equals 0. Then x power 2, 2x power 2 equal 9. Then x power 2 equal 9 over 2. Then x equal to negative positive square root 9, 3 over square root 2. So we have two x-intercepts point, negative 3 over square root 2 and positive 3 over square root 2, since these 2 points belong to the domain of the function negative 3 to 3. To find the interval of increasing and decreasing, find the sign of the first derivative before and after this critical point, negative 3 over square root 2, 3 over square root 2. Before negative 3 over square root 2 and 3, take 2.5. 9 minus 2.5 square, it is positive, of course. 5 over 2 square, 25 over 4, times 2, 25 over 2, 12.5, negative 12.5 plus 9, it is negative value. Between negative 3 over square root 2 and positive 3 over square root 2, take 0. 0 plus 9, positive value. After 3 over square root 2 to 3, take 2.5. 2.5 square times negative 2 plus 9, it is negative value. Therefore, the function is decreasing on these intervals 3 to negative 3 over square root 2, union 3 over square root 2 to 3. This is the interval of decreasing. And the function is increasing on the interval negative 3 over square root 2 to 3 over square root 2. The function here is increasing. And the function has local minimum value at negative 3 over square root 2, f of negative 3 over square root 2. This is the point of is minimum value, and maximum value at 3 over square root 2, f of 3 over square root 2. To find the inflection point and intervals of concavity of this function, we find the second derivative of the function if w prime of x equal to the denominator square root 9 minus x power 2 times the derivative of the numerator negative 4x plus 0 minus the numerator negative 2x power 2 plus 9 times the derivative of the denominator negative 2x over 2 times 9 minus x power 2 over denominator square 9 minus x power 2 equal to negative 4x times square root 9 minus x power 2 minus reduce 2 with 2 negative 2x power 2 plus 9 times negative x over square root 9 minus x power 2 over 9 minus x power 2 equal to negative 4x times square root 9 minus x power 2 minus negative x times negative 2x power 2 2x power 3. Negative x times 9 minus 9x over square root 9 minus x power 2 over 9 minus x power 2 equal to negative 4x times square root 9 minus x power 2 plus negative 2x power 3 plus 9x over square root 9 minus x power 2 over 9 minus x power 2 equal to the common denominator for the two terms in the numerator square root 9 minus x power 2 times negative 4x square root 9 minus x power 2 negative 4x 9 minus x power 2 minus 2x power 3 plus 9x over 9 minus x power 2 equal to square root 9 minus x power 2 times 9 minus x power 2. It is 9 minus x power 2 to the power 3 over 2. 1 plus half. Negative 4x times 9, negative 36x. Negative 4x times negative x power 2, 4x power 3 minus 2x power 3 plus 9x equal to 4x power 3 minus 2x power 3, 2x power 3, negative 36x plus 9x, negative 27x over 9 minus x power 2 to the power 3 over 2. Set it equals 0, cross multiplication, then 2x power 3 minus 27x equals 0. Factorize by x, 2x power 2 minus 27 equals 0. Either x equals 0 or 2x power 2 minus 27 equals 0, then 2x power 2 equal 27, then x power 2 equal 27 over 2, then x equal negative positive 27 over 2 under square root. Since square root 27 over 2 greater than 3 and less than negative 3, therefore this value not belong to the domain of the function of f. Then we have only one possible inflection point, x equals 0. Find the sign of the second derivative before and after 0 negative 3 to 0, 0 to 3. Before 0, take negative 1. 2 times negative 1 to the power 3, negative 2, plus 27, it is positive value. After 0, take 1. 2 minus 27, it is negative value, since the denominator is always positive. Therefore, we have in the interval of concavity negative 3 to 0, it is interval of concave, and 0 to 3, it's the interval of convex, and 0, 0 is an inflection point for this function, and the graph will be from negative 3 to 3. It is the domain of this function. The function is concave between negative 3 and 0, convex 3 to 0. This is the graph, and 0, 0 is an inflection point for this function. The function is increasing from negative 3 over square root 2 to 3 over square root 2, decreasing from negative 3 to negative 3 over square root 2, 3 over square root 2 to 3. Question number 18, is it possible for the graph of a function to cross its vertical asymptote? Explain. It is not possible for the graph of a function to cross the vertical asymptote, since the value of the vertical asymptote is not in the domain of the function. So the answer is no. 19. Is it possible for a graph of a function to cross its horizontal asymptote? Yes, it is possible for the graph of the function to cross its horizontal asymptote. For example, if we take f of x equal to 2x over x power 2 plus 1, the graph of this function is, the function has horizontal asymptote at 0, since the degree of the numerator is less than the degree of the denominator, and the graph is look like this. We have a horizontal asymptote at 0, and the function cross the point 0, 0. Question number 20. The equation of the function f of x equals 6 minus 2x suggests the existence of a vertical asymptote. What is the equation? Sketch the graph and verify that it does not have any vertical asymptote. The function looks like has a vertical asymptote at x equals 3, but if we set x minus 3 equals 0, then x equals 3 is a vertical asymptote if x equals 3 don't make the numerator 0. But if we substitute x equals 3 in the numerator, we see that the numerator will be 0. 6 minus 2 times 3, 0. Therefore, x equals 3, not horizontal asymptote for this function. And if we want to graph this function, we simplify this function as simplify by 3, by 2, 3 minus x over x minus 3 equal to negative 2 x minus 3 over x minus 3. Then the function is, the graph of a function is a horizontal asymptote parallel with x-axis intersecting with y-axis at negative 2. Question number 21. Find a function with a vertical asymptote at x equals 5. Then we have in the denominator x minus 5 and horizontal asymptote at y equals 0. We take any constant number in the numerator for example 3, then f of x equals 3 over x minus 5 has a horizontal asymptote at y equals 0 since the degree of the numerator is less than the degree of the denominator, and a vertical asymptote at x equals 5 since 5 makes the denominator 0. Find a function with a vertical asymptote at x equals 5, then we have x minus 5 in the denominator and a slant asymptote at y equal 3x plus 2. Then the function will be the equation of the slant asymptote 3x plus 2 plus 1 over x minus 5. Question number 23 and 24, identify the graph of the function f with its first derivative and second derivative. As you see, the graph on the red is the function for the function, and the graph in the black is for the first derivative, and the graph on the green is for the second derivative. Since the graph on the black is the graph of the quadratic function, and the graph in the green is the graph of the line of the linear function, and the graph of the red is the graph of the cube function. In the next question, the graph in red is a quadratic function, so it is for the function f. The graph of in black it's for the first derivative since it is a linear function with positive end, and the graph in green is for the second derivative since it is line parallel to x-axis. Question number 25 and 26 use the graph of the first derivative of the function f to sketch the graph of the function f. For question number 25, the derivative of the function is increasing is over x-axis from negative infinity to negative 2 and from 2 to positive infinity. Therefore, the function is increasing on these intervals. Also, the graph of the function intersects with x-axis at negative 2 and 2. Therefore, the function has a horizontal tangent line at negative 2 and 2. Therefore, the function is under x-axis from negative 2 to 2. Therefore, the function is decreasing on these intervals. Now, the function is, this is negative 2 and this is 2. The function is increasing from negative infinity to 2, decreasing from negative 2 to 2, and the function has an inflection point at zx equals 0. Therefore, we have, and the function is increasing from 2 to positive infinity. So this is the graph of the function of question 25. For question number 26, the function is over x-axis from negative, this is negative 3 pi over 2, this is negative pi, this is negative pi over 2, pi over 2, pi, and 3 pi over 2. The function is over x-axis from negative 3 pi over 2 to negative pi over 2. Therefore, the function is increasing on this interval. Also, the function has horizontal tangent line at negative pi. Therefore, negative pi is an inflection point for this function. Therefore, the function looks to be like this: convex, concave before negative pi, increasing from negative pi over 2 to negative pi over 2, decreasing from negative pi over 2 to pi over 2, since the graph of the first derivative is on the under x-axis, and the function has horizontal tangent line at x equals 0. Therefore, x equals 0 is an inflection point. This is the part of decreasing. The function is increasing from pi over 2 to 3 pi over 2 and has a horizontal tangent line at pi. Therefore, we have this graph. Question number 27. Suppose that f prime of x less than 0 for all x on the open interval 2 to 8. Explain why f of 3 greater than f of 5. Since 3 and 5 belong to the interval 2 to 8, to the open interval 2 to 8, and the function on this interval is decreasing, then the rule is when x1 greater than x2, then f of x1 less than f of x2. And since 5 greater than 3, therefore f of 5 will be less than f of 3. Question number 28. Use the graph to answer this 4 questions. Is the graph symmetric? It is clear that the graph of this function is symmetric with the origin. Is the function is periodic? Yes, the function is periodic, and its period is 2. Identify the local extrema on -1 to 1. This is -1. This is 1. We have a local minimum value at -12 and local maximum extrema at 1/2. Do you see any point of inflection on the open interval 0 to 1? The graph on this interval is convex and there is no any inflection point. See you next lesson.